The Product Development Center includes models that show two flume designs that detail the structures where air and water are introduced to the filter for backwashing the filter media. This static model is a demonstration of a front flume and two different ways of introducing air to the underdrain. The area here is the front flume where filtered water is collected, backwash water is distributed, and the air header pipe is located. In existing installations, if there is enough area in the front flume to not increase backwash water velocities, the air header with J risers is placed. The name J riser describes the shape of the pipe that takes air off the bottom of the header and introduces air to each underdrain lateral. If the air is not taken off the bottom of the air header pipe, water cannot exit the air header. If there is not enough room in the flume for the air header pipe, then the air is introduced from the top by these drop pipes. Here are different styles of drop pipes that feed each of the underdrain laterals. This static display also shows the grout retainer strips that are used over the flume to prevent fill grout from entering and filling the flume. Here are the anchor rods that are used over a flume to resist uplift due to the backwash water. After placement, the anchor rods are embedded in the fill grout as seen here. To place an anchor rod, holes are drilled at designated spots on both sides of the flume. Holes are cleaned, filled with a 2-part epoxy cement, and the rod section is placed. Once set and cured, this pull tester is used to verify the minimum strength of the cement bond. Finally, the leveling nuts are placed at elevation, the perforated bar is placed, and the locking nuts are placed on top to complete the assembly. This full-scale plexiglass model simulates a Leopold flat-bottom flume filter with one lateral. The flume on the right is called a flat-bottom flume because the flume is located at the same elevation as the filter floor. It requires no additional excavation that front, center, and H flumes require, so it is more cost-effective to build. Inside the flume is a baffle wall that has openings in the bottom. The backwash air enters the filter here at the top of the flume and passes over the baffle wall. The backwash water enters here at the bottom of the flume and passes through the openings in the bottom of the baffle wall. As we start the air, notice how the liquid level on the far side of the baffle wall is displaced, and air is distributed through an opening in the filter wall to the underdrain. The underdrain distributes the air and it exits through the IMS cap. Now we start the low-rate water. The liquid passes through the openings in the bottom of the baffle wall, through the opening in the filter wall, and the underdrain then uniformly distributes both the air and water. The Leopold flat-bottom flume filter design is significant because it can allow substantial cost savings in excavation and support structures.